Hello students, welcome to the video tutorial of Informatics Practices for class 12. Today we'll be discussing the third part of the chapter, Computer Networks. So in the previous video tutorials we have already discussed that what are different types of network, that is the LAN connection, the WAN connection, the MAN and the PAN connection. That is the local area network, the wireless area the wide area network, the metropolitan area network and the personal area network. Okay. Also, we have discussed that what are the most important choices that one should make when they are creating a particular network. Okay, so that choices were the cost, that is, it should be less in the cost and it should be flexible and it should be reliable. Okay, and we have also discussed about the point-to-point link, that is, it can be possible that we are transmitting and receiving from the same connection or the data cable, and there is a second possibility also that we are transmitting from the other cable and receiving from a different cable. Okay, so this was about the point to point link. Now today we are going to discuss about the star topology. Okay, now this star topology is basically consisting of a central node, okay, to which all other nodes are connected by a single path. Okay, topology, we are already knowing that topology is actually the way in which the connections are being made in a particular network. Okay, that is how the nodes are joined with a particular server. Okay, so here you can see that the topology consists of a central node. Here it is a central node to which all other nodes are connected by a single path. Okay, so individual paths are there for all the other nodes. It is the topology used in most existing information networks involving data processing or voice communications. So basically it is used in the common example is that IBM 370 installation. So all those systems are going to use this star topology. Okay. So let us see some advantages of the star topology, that what are the basic advantages which we are going to use if we are creating a network in the star topology. Okay. So first thing is the ease of service. Why there is a ease of service? Because the star topology has a number of concentration points where connections are joined. Okay, these provide easy access for service or reconfiguration of the network. Now, what it is uh, expressing this, that where connections are joined, here we are having a number of concentration points. Okay, so star topology is a number of concentration points. This these provide easy access for service or reconfiguration of the network. Because of this, it is easy to create some concentration points or to create some configuration of the network. Even if there is a problem in the configuration, we can reconfigure it. Okay, so all these things are possible because of the presence of the ease of the service in the star topology. Okay. Second thing is one device per connection. Now connection points in any network are inherently prone to failure. Now you are knowing this thing that whenever we are creating a network, there are certain connection points, and that is a possibility that they are prone to failures. Okay, there may be loose connection or the particular network is not being accessed through a particular point because of some system failures. So that is a possibility that it will be prone to failures. Okay, so what is there in the star topology? In the star topology, failure of single connection typically involves disconnecting one node from an otherwise fully functional network. Now, there is a high probability that if there is any error in the network, so it may be caused just because of the disconnection of the node from fully functional network. Suppose if this system is having a problem, okay, so the problem cause can be because it has been disconnected from the fully functional network. Okay, so this is a prior condition where the failure can be there. Otherwise, it is having a proper source of networking, and it is going to rather fail. Okay, very rare possibility is that the system is going to fail. Okay, now the next thing is centralized control problem diagnosis. Now the fact that a central node is connected directly to every other node in the network, that means that faults are easily detected and isolated. Now, since you know that the main central system is there and rest of the systems are joined to the single individual path, so it is easy to diagnose the problem. Okay, suppose a particular node is having the problem, and you want to check why this is not having getting a connection from the network. So already you know that it is having a single path, and that single path is not dependent over the other independent paths. Okay, So it is sure that if it is a problem there in a network in a particular node, then that means that that single path of that node is having some particular configuration problems. Okay, so you need to correct that single path, and if you are going to correct that single path, that means the problem of the networking can be sorted out. Okay, it is a simple method to disconnect pairing nodes from the system. Now, if suppose you are having the problem in the node and you are not able to correct it, you are going to disconnect it from the system. So it is not going to cause problem for the other nodes because all other nodes are having their independent paths for the particular central system. So even if this particular node is having problem, you can remove it from the system and rest other nodes are going to work properly. Okay, so it is an advantage of the star topology. Now, simple access protocols. Any given connection in a star network involves only the central node. In this situation, contention for those who has control of the medium for the transmission purpose is easily solved. Thus, in the star network, access protocols are very simple. Now, the accessing protocol, that means if you want to access a particular data, then certain set of protocols are need to be followed. That is, certain sets of rules are to be made. So, any given connection in a star network, it involves only the central node. Okay, so all the accessing will be done from the particular central node. Okay, in this situation, contention for who has control of the medium for the transmission purposes is easily solved. Now you don't have to be worried that which system is having the configuration to allow the access. Okay, you know that all the access is being done with the help of central node. So there is no confusion that this node is having data or this node is having data. So all the access is being done with the help of this central node. Okay, so you don't have to worry that which system or which node is having the particular data. That's why the protocols which are meant for this central system are very simple, and that's why it is creating a simple access protocol for the star topology. Okay, now let's see what are the disadvantages. So the first disadvantage is the long cable length. That is, since we are going to use different individual paths for each system, that means it is going to create a long cable length. Okay, so because each node is directly connected to the center, the star topology necessitates a large quantities of cable, while the cost of the cable is often small. Congestion is a cable duct, and maintenance and installation problem can increase cost considerably. Now obviously there are multiple paths, so there has to be a maintenance of the multiple paths, so indirectly it is going to means increase the cost of the networking. So long cable length is actually a disadvantage for the star topology. Now second thing is that the difficulty to expand. Now the addition of a new node to a star network involves a connection all the way to a central node. Okay, so if you want to add a particular network or a particular node in the system, so you need to directly add it to the central system. So it may cost you some again long cable length because you cannot join it to a particular node. You have to join it to the central system or the central node. Okay, so that is going to create a difficulty in the expansion of the network. That means if you are going to add a new network, add a new node in the network, so it will create some expansion problems. Okay, central node dependency, obviously all the thing is being handled by the central node, so it is a too much dependent system over the central node. So if the central node in the central star network fails, the entire network is rendered inoperable. Obviously if the central node is going to fail, all the accessing of the data is going to stop. Okay, so the system cannot be resumed until the particular central node is going to be connected. Okay, so if it fails, that means the entire operation of the system or the network is going to fail. Okay, this introduces heavy reliability and redundancy concerns on the node. Okay, now the star topology has found extensive application in areas where intelligence in the network is concentrated at the central node. So basically, you are going to use the star topology where all the things are heavily dependent on the central node. Okay, so according to the demand or the purpose of the networking, you can use the particular star topology. Okay, our next thing is the bus or linear topology. It is also known as linear topology because it is creating a linear path. Okay, another popular topology for data network is the linear. This consists of a single length of the transmission medium. Okay, so single wire is there for the communication. Okay, it is actually a normal coaxial cable onto which the other various nodes are attached. You can see from the single node, other nodes are attached. Here is the server, here is the printer, there is the workstation. All the different nodes are connected through their own cables with the particular central cable or the coaxial cable. Okay, So this topology is used in traditional data communication network where the host at one end of the bus communicates with several terminals attached along its length. So suppose a host is there at a particular end of the bus, so it can communicate with other systems through this particular central wire or the coaxial cable attached. Okay. Now the transmission from any station travels the length of the bus in both direction and can be received by all other stations. Okay, so the transmission is being happened with this coaxial cable. The entire information is there in this. So whatever the node is there which is going to receive the signal is going to receive it through this coaxial cable only. Okay. Now data is transmitted in small blocks known as packets, and each packet has some data bits plus a header containing its destination address. A station wanting to transmit some data sends it in packets along the bus. The destination device, on identifying the address on the packets, copies the data onto its disk. Okay, now what will happen if you are sending the information from this particular coaxial cable? Then the information is having its own header address. Okay, at which particular node or particular station it has to go. Okay, so accordingly, getting the address, the particular workstation will access that data and copy it into its own system. Suppose you are sending it to this workstation 1. Okay, so the information will travel along this bus and it will have a particular header. Now this workstation will recognize that it is my own address, so it will receive it and it will copy it onto its own system. Okay, so in this similar way all other systems are going to get it from this coaxial central node or the central wire. Okay, now let's see the advantages of the linear topology. So the advantages are the short cable length. Obviously, there is a single node in the center, and rest others are joined with a small cable. So it is going to minimize the cable length. Okay, and simple writing layout. Sorry, wiring layout. Okay, because there is a single common data path connecting all nodes, the linear topology allows a very short cable length to be used. Second thing is the resilient architecture. The linear architecture has an inherent simplicity that makes it very reliable for a hardware point of view. There is a single cable through which all the data propagates and to which all nodes are connected. Now all the things is dependent upon this central node, sorry, the central cable. So you can understand this thing that the transmission of the data is very simple. It is not a very complex procedure. So because of this, the design becomes very simple. Okay. Now you can say that is the design means the architecture. So you can say it is a resilient architecture. Okay. Now it is easy to extend also, because if you want to add a particular system, you can directly attach it to this central wire. Okay, the coaxial cable. Once you are going to attach it, it is going to receive the signal according to its address. Okay. Now let's see the disadvantages of the linear topology. First thing is the fault diagnosis is difficult. Now why it is difficult? Because control of the network is not centralized in any particular node. Okay, so this means that detection of the fault may have to be performed from many points in the network. In the star topology, you are knowing that all the data is being transmitted from a particular central node, but here there is no central node. Okay, so if there is a fault, you need to diagnose the fault in the whole system of the whole network. Okay, there may be a possibility that the problem is from the printer, and that's why this particular node is not getting the information. So you have to check linearly or the sequentially in all the system from where the problem is arising. Okay, that is the disadvantage of the linear topology. Okay, now fault isolation is difficult. That is, in the star topology, defective node can easily be isolated from the network by removing its connection at the center. But if you're talking about the bus topology, if a node is faulty on the bus, it must be rectified at that point where the node is connected to the network. Okay, so in this you cannot remove it, because there is a possibility that the network is, or the whole data is traveling through this serially. Okay, so even if one system is going to have a failure, that means it is going to create a failure in the complete system. Okay, the complete network. Repeater configuration: when bus type network has its backbone extended using repeaters, reconfiguration may be necessary. Okay, so in that condition, when the uh, particular repeaters are being used, so the reconfiguration will become necessary at that point. Okay, nodes must be intelligent. Each node on the network is directly connected to the central bus. This means that some way of deciding who can use the network at any given time must be performed in each node. Now, obviously, the whole data is being transmitted from a single coaxial cable, so the nodes must be intelligent. They should have a particular organization in working, because they have to understand that which node is going to use the network at which time. Okay, because it is totally dependent upon the single node or the single coaxial cable. So that means there should be some way of deciding that who can use the network at a given time. Okay, because all the nodes cannot perform parallelly, cannot work parallelly. Okay, so this was about the bus topology. Okay, now the ring or the circular topology. So what is the ring topology? Obviously you can see here that all the nodes are joined in a particular form of ring. So what is there? It is the data is accepted from one of the neighboring nodes and is transmitted onwards to another. Thus data travels in one direction only from node to node around the ring. Now, what actually this ring topology is having is that topology is in a circular way. Okay, so each node is connected to two and only two neighboring nodes. Connected to two and only two. That means you can see here if one system is there, so either it is connected from the front system or the back system. It is not connected from this system. Getting it? So all the nodes are having connection from either the previous one or the next one. So it is not having any relation with this node. Okay, so in this way the ring topology is created. So it is important to note that the data passed through rather than travels past each node. This means that the signal may be amplified before being repeated on the outward channel. Now what you are saying here is that means when the data is being passed, so the data is being passed through rather than travel past. That means what? If you are passing some information, it is passing from a particular node and then it is passing to the second node and it is passing to the third node. Okay, so it is a condition of pass through. Okay, not travel past. Okay, in this what will happen, that the signal may be amplified before being repeated on the outward channel. Okay, so if the signal is being transmitted and being transported from one system to other, there's a chance, there's a probability that it may be amplified before repeating. Okay, amplified means you understand only that it can be increased in the signal strength. Okay, so what are the advantages of ring topology? It is having a short cable length. Okay, no wiring closet space required and suitable for optical fibers. Okay, where the disadvantages are that the node failure causes network failure. Now, if any node is going to have a failure, okay, the transmission of the data on the ring goes through every connected node on the ring before returning to the sender. If one node fails to pass data through itself, the entire network has failed. Obviously, if the information is being traveled through different nodes, so if you have passed the particular information from this system to this system, and if this system is not receiving it, okay, or it is not sending it, that means it is not going to reach to this system. So obviously it is going to create a failure in the network. Okay, so obviously there is a dependency over the other nodes. That's why you are saying that node failure causes network failure. Okay, now difficult to diagnose fault again, since it is connected by one to one configuration. So what will happen, there is a problem or the difficulty in diagnosing the faults. Okay, so if a particular node is having the failure, that means one will affect all others with a serious implications for fault diagnosis. It may be necessary to examine a series of adjacent nodes to determine the faulty one. Obviously, if you are having a particular problem in this node, then you have to search the problem in this and this both, because it is the information is being passed from these nodes. Okay, so if suppose if you are checking this node and this node, so if you are having a problem in this node, so it is rectified here only. But if it is correct here and it is correct here, you have to check other adjacent nodes from this system. For this system you have to check this, and for this system again, if a particular system is joined here, you have to check that system. Getting it? So all the faults are being diagnosed by checking their adjacent system. So it is creating a complexity in checking the fault. Okay, so fault diagnosis is a bit difficult in ring topology. When the network reconfiguration is difficult, again it is similar to the bus topology in this condition, because it is not possible to shut down a small section of the ring while keeping the majority of it working normally. Okay, so obviously the systems are dependent over each other, so you cannot remove a particular system from the network, because if you are going to remove it, it will create problem for majority of the systems working. Okay, Now it is told that a repeater amplifies the signal being transmitted on the network. You already know this. And what is the use of repeater? Repeater is going to amplify a signal. So if there is a loss of the signal, it will amplify it and it will strengthen that particular data which is being transmitted. Okay. Next thing is the tree topology. Now in tree topology, you can see there is a branches, certain set of branches being created here. So now let's see how it is being joined. Variation of bus topology is the tree topology. The shape of the network is that of an inverted tree. Inverted tree, you can understand this. Okay. Now with the central root branching and sub branching to the extremities of the network. Okay. Now here you can see there is a the tree topology being represented here. It is a single source. Okay. From here the branches are being divided, and further on these branches there can be sub branches also. Okay. Now transmission in this topology takes place in the same way as in the bus topology. In both cases there is no need to remove packets from the medium, because when a signal reaches the end of the medium, it is absorbed by the terminators. In bus topology also we were having the terminators at the end which were stopping the absorbing of the signal, were being done with the help of this terminators only. Okay. So the tree topology is also having the terminators to absorb the signals at the end of their connections. Okay. Now the tree topology is best suited for the applications which have hierarchical flow of data and control. Hierarchical, you know only that it is in a particular set of order, that it will reach there, then from here it will reach to the particular set, then from here it will reach to the particular subset. Okay, so there is a hierarchical order of the data. So in that case, you are going to use the tree topology. So in the tree topology is a modification of a pure network topology. Bus topology, it is a hybrid topology. Okay, so actually tree topology is a hybrid topology. Okay, so it is a hybrid topology of what? Bus topology and the pure network topology. Now let's see the advantages. It uses point-to-point wiring for individual segments. It is supported by several hardware and software vendors. And disadvantages are overall length of each segment is limited by the type of cabling used, and if the backbone line breaks, the entire segment goes down. Obviously it is dependent upon different branches also. So if a particular branch is going to break from the center, so the sub branches are also going to have problems in that. Okay, so that's why you are saying if the backbone line breaks, the entire segment goes down. Okay, so it is more difficult to configure and wire than other topologies. So since it is having a bit complex structure, so if there is a fault in the wiring, so it will create difficulty in configuring the network. Next, the mesh topology. So in this topology, each node is connected to more than one node to provide an alternative route in the case the host is either down or too busy. Okay. Now what it is mentioned that in this topology, each node is connected to more than one node. Earlier we were having each node connected to a single node, but here we can see each node is connected to the multiple nodes. Okay. So what will happen here in the case if one node is to provide a particular information, but if it node is busy, so it can have a information from the other alternative nodes also. Okay, so that totally it is mentioned that each node is connected to more than one node to provide an alternate route in the case the host is either down or too busy. Okay, so it is an extension of P2P network. So point-to-point network is having a particular extension here in this mesh topology. So you are having multiple points. Okay, so that mesh topology is excellent for long distance networking because it provides extensive backup, rerouting, and pass-through capabilities. Okay, now let's see the advantages of the mesh topology. Each connection can carry its own data load. Okay, you don't have to be worried upon the central system only, because each connection can carry its own data. It is robust and provides security and privacy. And in this topology, fault diagnosis is easy. Okay, you don't need to explain all these things. You know this, that fault diagnosis will become far too easy here, because you can understand that if this system is having problem, that means multiple sources are there. So if it is not getting the information from here, it is getting the information from here. That means this system is having problem. Try to understand this. The information is being traveled from here to here to here. Now suppose if this system is not getting the information, There can be possibility that this system is having problem. So if this is having problem, that means the information should come from here to here because there is an alternate path. So if the information is getting means coming to the system from here to here, that means the problem is there in this system. So easily it can be rectified. Okay, so suppose if this system and this system both are giving the connection, so in that case you are having problem in this system because alternate paths are there. Say these two systems are giving you the connection properly and data properly, so that means the connection from this system is weak. Okay, so this network is having problem. Now advantages of mesh topology is there. Each connection we have already discussed, and the disadvantages of mesh topology includes the installation and configuration is difficult. Obviously, it is a complex structure because we are creating multiple nodes. Okay, and the cabling cost is more for mesh topology, and the bulk wiring is required for mesh topology. Got it, everyone? Now the last one is the fully connected. So you can understand it from the figure itself. That when in network, each host is connected to other directly. That means all the hosts are connected with each other. So that will create a fully connected network. Okay. There is a direct link between each host, then the network is said to be fully connected. This characteristic is termed as fully connectivity, full connectivity. Okay. Now that's enough for today, and we will discuss the other part in the next video section. Okay. Till then, students, take care. Thank you.